Good day, everyone. I am Mariella Kris Pimentel, together with my group mates, Geeann Cruzado, Fridelyn Peñaflorida, and Geriq Joeden Perilla. And we will be discussing assessing the fit of a simple linear regression model. So dito po, ang gagamitin nating example ay ang Butler Tracking Company. Doon po sa mga previous discussion ay nakapag-develop na ng estimated regression equation which is yung y sub I is equals to 1.2739 plus 0.0678. Ito po ay gagamitin natin para ma-approximate yung linear relationship doon sa dependent and independent variable natin. Where dito sa case na ito ay yung miles traveled is the independent or the x and the travel time in hours is the dependent or the y kasi nagabari po yung time depende sa kanyang speed. So to begin with, we will be going to develop the intermediate calculations which is referred to as the sum of squares.
So, ulitin ko na lang.
Mga ka Geeann.
Oo, ulitin ko. So, the sum of squares. Sum of squares due to error is denoted by the formula SSE is equal to summation of quantity y sub I minus y hat sub I squared. This formula, y sub I, represents the actual observed values and the y hat sub I represent the predicted values from the regression equation. The SSE is the sum of squares differences between the actual values and the predicted values across all observation. Nag-provide rin ito ng mga measures of the total error in the prediction made by the regression model, specifically in terms of how far of the observation predicted values are from the actual values. The larger the SSE, the more error there is in the prediction. Dito, ang mga errors ay naka-squared so that positive and negative deviation don't cancel out each other. And this result expressed in the squared units of the dependent variable. Next slide po. So, next is, yung table 7.2 po ay nagpapakita ng mga calculated required values to compute the sum of squares due to error or SSE for the Butler Tracking Company. The squared residual or the error for each observation in the data is shown in the last column in this table, yung nakabox na 8.0288. And after computing and squaring the residual for each driving assignment in the example, yung sum na na-observe natin, yung SSE nga ay yung 8.0288 r squared. Ito ay nag-measure ng error gamit yung estimated regression equation y sub I is equal to 1.2739 plus 0.678 x sub I, which is pinapakita dito sa figure sa may kanan, yung nakabox na equation, para ma-predict yung travel time for the driving assignment ng mga sample. Next slide.
So, next naman po ay yung SST o yung total sum of squares. So, ang total sum of squares is an important concept in statistics, particularly sa analysis ng linear regression. Ito ay kumakatawan sa kabuuang pagbabago ng dependent variable which provide a measure of the total variability of observed values from their mean. So, ang SST ay isang pangunahing bahagi ng pagsusuri ng fit ng regression model dahil ito ay baseline na sukat na variability na dapat ipaliwanag ng model. So, ang formula ng SST ay yung nasa baba po. So, dito yung y sub I ay ang dapat of bawat observed value at ay yung isang y ay yung mean ng bawat observed values. The difference between each observed value and the mean is called deviation. And squaring this deviation gives us the squared deviations Ang kabuuang sum ng mga square deviation ay nagbibigay ng SST, which shows the total variability in the data. So, ang diagram na makikita natin ay nagpapakita ng pagkakaiba ng bawat data mula sa average, providing a visual representation of total variability. So, sa isang scatter plot, the vertical lines connecting each observed value to the mean represents the deviations. A higher value of SST indicate greater variability in the observed values, which may suggest a more complex relationship between the dependent and independent variables. So, next naman po ay yung SSR o yung sum of squares due to regression. So, ito po ay isang mahalagang bahagi ng pagsusuri ng linear regression na nagbibigay diin sa kung paano ang isang model ay naglalarawan ng variability ng data. Ang SSR ay sumusukat sa bahagi ng variability ng dependent variable. For example po, yung travel time na ipapaliwanag ng regression model. So, in simple terms, it shows how well the model predicts values based on the independent variables o yung miles traveled natin. So, ang formula po nito ay yung nasa baba. So, dito yung y sub I ay ang predicted value mula sa regression equation. At yung isang y po ay mean pa rin ng observed values. So, a higher SSR indicates that the model is better at explaining the variability in the data. So, sa context ng Butler Tracking Company, ang SSR ay nagbibigay ng halaga na 15.8712, which shows the model can explain a significant portion of the variability in the travel time. So, next naman po, yung SST is equal to SSR plus SSE. So, mahalaga ang relasyon ng mga sums of square na ito na nakasaad sa equation. So, ang SST, yung total sum of square, represents the whole variability of the dependent variable. So, this equation shows that the total change in the dependent variable is divided into the part explained by the model SSR, and the part is unexplained, SSE. Sa example ni Butler Tracking Company, ang kabuoang sum ng SST ay 23.9 at ang 64.41% nito ay nagpapaliwanag ng model, indicating a good fit in the regression equation. So, sa isang scatter plot, makikita ang observed values, predicted values, at ang residual bilang vertical lines. So, these vertical lines represent errors, and shorter they are better the fit of the model. So, the regression line shows the trend followed by the data, while the explained variation SSR is the part of variability explained by the regression line, and the unexplained variation SSE is the part of the model does not explain. So, next slide.
Now, we will move on to the coefficient of determination. Next slide po. The coefficient of determination, or R squared, is the ratio of SSR to SST. Ito po yung number mula 0 to 1, which tells us the proportion of the total variation in the data that is explained by the model. So if R squared equals 1, it means that the model is perfectly explains the data, or all variability is explained by the regression. And if R squared equals 0, it means the model does not explain any of the variability in the data. So, the higher the R squared, the better the model fits the data. The figure 7.9 po represents the coefficient of determination, which is calculated as R squared equals SSR over SST, which means po na yung SSR ay sum of squares for regression. And ina-measure niya po yung variability in the dependent variable y that is explained by the regression model. So in other words po, it's the part of the data that your model is able to explain or predict. Yung SST naman po, or total sum of squares,
is the total variability in the dependent variable. So it represents the sum of variability that can be explained by the regression model or SSR. And yung variability naman po that can't be explained is SSE, which is the error. Next slide po. The coefficient of determination po is poorer fits will result. So, there are three sums of squares. Yung una po is yung SST, SSR, and SSE yung pangatlo. So, yung SST po, yung total sum of squares, represents the total variation in the dependent variable. It measures how much the data points differ from the mean of the data. Yung SSR naman po, yung sum of squares for regression, ina-represent naman po niya yung variation sa dependent variable that the regression model can explain. Then yung SSE, yun po yung sum of squared errors. Ina-represent po niya yung variations that the model cannot explain or the error in the model's prediction. So to sum it up po, a value of r squared equals 1 means a perfect fit. And as the value gets closer to 0, the fit becomes worse po. So next slide po. So the key idea here po is that poorer fits will result in larger values for SSE. So, ibig sabihin po, hindi maayos na naiipaliwanag ng model ang data. And when SSR equals 0, the model explains none of the variability. And yung SSE naman po equals SST, indicating the worst fit. So, the ratio is called the ratio SSR over SST is a measure of the model's goodness of fit and is known as the coefficient of determination or R squared. So, yun po yung sinasabi na the ratio is called the coefficient of determination and it is denoted by R squared. Next slide po. So, the image shows that for Butler Trucking Company po, R squared is calculated as 0.6641. This means that 66.41% of the variation in quarterly sales can be explained by the estimated regression equation po. So the example demonstrates how the coefficient of determination can be used to evaluate the effectiveness of regression model in predicting outcomes. In this case po, the regression model for Butler Trucking Company can explain 66.41% of the variation in quarterly sales, suggesting a relatively strong relationship between the independent and dependent variables. Next slide po.
So, ngayon naman po ay ating pag-aaralan ang paggamit ng Excel chart tools to compute the coefficient of determination. So, based on the data here, we will select the data under miles and time, and after highlighting the data, we will go to the insert function. Then, on the chart, we will click the scatter. Next slide po. So, kapag po meron na tayong scatter chart, right-click lang on any data point, then select Add Thread Line. Next slide. So, when the Format Thread Line task pane appears, we need to select Display R-squared value on chart in the Thread Line options area and also display the equation. So, as you can see, this displays the scatter chart, the estimated regression equation, the graph of the estimated regression, and the coefficient of determination for the Butler Trucking Company data. And we see that R squared is equal to 0.6641. Same lang din dun sa nakuha natin kanina. And that's all for our report. Thank you po.